Welcome to the week 1 review video. So the way that I'm trying to do this and the setup for this, how this should work, is that every week I will be picking out for one of your lessons 6 topics that you should have covered before, and I'll be setting 5 sets of questions on those 6 topics. So I've done 30 questions altogether. And I think that the best way to try and do them is to try and do a set of questions every day. So do the first set on the Monday, the second set on the Tuesday, the third set on Wednesday, and so on. So the idea is you keep coming back to those topics and make sure that by the end of a week you're really secure and really confident in your knowledge on those topics. To help you with that, what I have done is I've done a video of me going through the first page. So if there's any of the questions you're not sure about on the first page, you can have a go at them, watch this video, do try them first, and then see where you need to maybe adapt your thinking and change your thinking a little bit. If you are then still struggling on the topics, do look up the topics on Hegarty Maths and do some more practice on them. The idea is to make sure that we don't lose knowledge of things that we have done before. So these are our 6 topics for this week. I'm not going to waste any more time talking about them. I'll start going through them, and then, as I said, check the answers that I get against what you've done. Check the methods, and then hopefully that will help with trying the other questions in this set across the rest of the week. So, first topic, multiplying and dividing decimals. So I'm being asked to do 0.24 times 6.5. Okay, what I want to do when I'm multiplying decimals is I want to get rid of the decimals. So I want to think of this really as 24 times 65. 0.24, I'm multiplying that by 100 to get 24. 6.5, I'm multiplying by 10. To get 65. So altogether, if I've multiplied by 100 and multiplied by 10, the answer that I get here is going to be 1,000 times bigger than the answer would be to the decimal question. So whatever answer I get here, to go back up, I'm going to need to divide it by 1,000. 24 times 65, you might have a variety of ways that you do it. I'm going to use the column method here, but if the grid method works better for you, then that is absolutely fine. I think the grid method is a really good method to do multiplications if you're not quite as confident on them. So I think the answer to that should be 1,560. I need to divide by 1,000, so it should be 1.560. I don't need to write that 0 on the end. So 0.24 times 6.5 is 1.56. And the way that I know that is because 24 times 65 is 1,560. And to do 24 times 65, how I've changed this initial question is by multiplying 0.24 by 100, multiplying 6.5 by 10 to get rid of the decimals. Decimals don't work with column multiplication. Okay, what I see quite a few people doing is doing column multiplication, keeping the decimals in, and then adding them in at the bottom. And you're really just guessing at where you're adding them in at that point. And you might be quite good at guessing them. You might use estimating to do that, which will usually help you get the right answer, but I'd like you to be confident in knowing you're putting the decimal point in the right place and knowing why it is the right point. Okay, to do divisions, actually having decimals on our numerator on our divisor isn't a problem. It's here. It's what we're dividing by being a decimal that's the issue. So the way that I like to think about this is to think about it as a fraction. So it's 16.7 divided by 0.8. And now I can use equivalent fractions to make this a lot easier. I can multiply the numerator and denominator by 10 to get 167 over 8. I don't much care that I've made the numerator an integer. It's nice, but I'm not bothered about that. What I'm focused on is I wanted to multiply the numerator and denominator by 10 to find an equivalent fraction. So it's going to have the same value because it's equivalent to this fraction here. I wanted to find an equivalent fraction where the denominator was an integer, because then actually doing 167 divided by 8 is a lot more straightforward. So I'm just going to use the standard bus stop method to do that here. Okay, again, you can use whatever method works best for you. I think it should be 20. That's not right at all. Sorry, this shouldn't be a 5 here. That should have been a 6 down there. So 8's into 67. Remained 4. So we get 20.875. Okay, sorry for the slight mess on that question. Brain's still waking up a little bit this morning. Okay, topic number 2, prime factorization, writing 240 as a product of prime factors. So what I want to do here is split this off as a product, so means multiplying factors, numbers that go into 240, and I want them to be prime. So I'm first going to start off by splitting it off into 2 numbers. The most common initial pair I think that people would write are 2 and 120. I'm not going to choose those, so I want to get my numbers split off as quickly as possible. So I'm going to choose 24 and 10. Now neither of those are prime, so I can't stop any of my branches there. I need to keep breaking these down. 24, can do that as 4 and 6. 4 would split off into 2 times 2. I'm circling those because 2 is a prime number. 6 is 2 times 3. 10 would split off into 2 and 5. And again, all of these numbers are prime. I'm not circling them just because I feel like it. I'm circling them because they're prime numbers, so I can't split them off any further. I can't find any more factors. The only factors are 1 and themselves, and that doesn't break it down any. So 240 is 2 times 2 times 2 times 2. So I've got 1, 2, 3, 4 lots of 2. 2 to the power of 4 multiplied by 3 multiplied by 5. And just ticking those is a really nice way of me making sure that I include all of them. Okay, the reason I know that's equal to 240 is because, well, 2 times 2 is 4, so that's where 2 of my 2's are going. This third 2 and this 3 make 6, and then multiplying those 2 together gives me this 24. Multiplying them by the other 2 and the 5 is the same as multiplying them by 10, which gives me 240. So it's just working my way back up there. The next one, orders of operation. So you'll be probably familiar with BIDMAS. I don't like using BIDMAS. I prefer thinking of it as this pyramid. So we've got brackets, then we have powers, so squares and square roots, then we have multiplication and division, then we have addition and subtraction, so pyramid, something like that. On this, the reason why I prefer that pyramid is because multiplication and division have equal priority. Addition and subtraction have equal priority as one another. So we just do those from left to right, unless we've got brackets telling us to do one before the other. BIDMAS makes us think that division is a higher priority than multiplication, or addition a higher priority than subtraction, when it's not. So here, what have I got that I need to be dealing with first? I've got these brackets here. I've also got power here, so an indice. So they're my first 2 priorities, and I can do those both at the same time because there's not a bracket involved in this, there's no powers involved in this. So it's really important when you do this to write things out in the same order. Don't start moving the order around and write whatever you've done first, whatever part of the calculation you've done first at the front, because that can change the answer. So 2 times 3 squared, so instead of writing 3 squared I write 9. I'm doing this bracket, so 4 plus 8 is 12. I'll subtract 12. Now I've got multiplication and subtraction. Multiplication is a higher priority than subtraction, so I do the multiplication first. 2 times 9 is 18, so we've got 18, take away 12. which is 6. Okay, when we break it up step by step like that, very straightforward. You might think it's straightforward anyway, but people do tend to make quite a lot of mistakes on them. Okay, in the second example, you can see we've got the same numbers here, but the brackets have moved. We'll see what difference that makes to the answer. So we need to do brackets first. So now I can't do anything with this power yet because I need to do the brackets first. So 2 times 3 is 6. So instead of writing 2 times 3, I write 6. Everything else stays exactly where it is. Okay, 6 squared, because I'm going to do my square numbers first. I've got a subtraction and addition. The power takes priority. So 6 squared is 36. So we've got 36 minus 4 plus 8. And then I can just do this from left to right. 36 subtract 4 plus 8. 36 take away 4 is 32. Plus 8 is 40. Okay, on the bottom row, we've got laws of indices. So there's broadly 3 laws that we might want to remember. When we're multiplying we add the powers. When we're dividing, we subtract the powers. And when we've got brackets, we multiply the powers. We're not going to use all of them at the same time in these questions, but we are going to try and work on all of them at some point. So here I've got 3a to the power 5 times 2a squared. I'm going to sort this out first. I'm still using my orders of operation effectively. So the squared I want to look at first. So 3a to the power 5. 2a squared is 2a times 2a. I've got 2 times 2 is 4. A times a is a squared. Okay, don't forget to apply the power to that number as well in questions like that. Now, we know when we multiply, we add the powers. So I've got a to the power of 5 and a to the power of 2. So that's 7 lots of a being multiplied together altogether. To use the word altogether too much. And now we've got these numbers to deal with as well. 3 times 4 is 12. Some people will be tempted to add those, but we're not adding them. There's a multiplication in the middle. The reason people would be tempted to add those is because they're adding the powers, but this 3 and this 4 aren't powers, they're coefficients. They're things that are being multiplied. We can think of this as 3 times a to the power of 5 times 4 times a squared. Again, a similar thing here. Just because I'm dividing with powers doesn't mean that this 8 and this 2 don't divide in the normal way. 8 divided by 2 is 4. A to the power of 6 divided by a cubed is a to the power of 3, because 6 take away 3 is 3. So I've got 6 a's being multiplied together. I've got rid of 3 of them. Okay, expanding and simplifying. So we should be quite familiar with expanding brackets. I'm very happy for you to use the grid method here to do some of these. 8x minus 32 minus 3x plus 6. I suspect if people have not got the correct answer on this one, it will be because they've done negative 3 times negative 2, but not got positive 6 there. So make sure that when you're expanding the second bracket, you include this sign in here. 8x take away 3x is 5x, negative 32 plus 6 leaves me subtracting 26. And for the bottom, again, I'm a very big fan of the grid method. We've got 2x minus 4, x minus 2. 2x times x is 2x squared. X times negative 4 is minus 4x. Minus 2 times 2x is minus 4x. Negative 2 times negative 4 is positive 8. So I've got 2x squared minus 4x is minus 8x plus 8. Okay, and I can't simplify that any further because the x squared and the x aren't like terms. Okay, the last skill, forming equations. So it's quite popular exam questions in the new style of GCSE, to be given a shape or a situation and be expected to solve an equation that you need to set up yourself. So it says form an equation given a perimeter of a rectangle is 18. So what I need to do is I need to find out algebraically what the perimeter of a rectangle is. Well, this side is 2x plus 5 because it's the same as the side opposite, and these two sides are equal, so that is x. So my perimeter are all of these added together. 2x plus x plus 2x plus x is 6x. I've got this 5 and this 5, that's 10. So that is my perimeter, 6x plus 10. If I add up all of those, I get 6x plus 10. It tells me that the perimeter is 18, so 6x plus 10 is equal to 18. And in a GCSE question, it'd be quite common for them to want you to solve that, to maybe do something else with it. I'm just happy with us forming equations. We're going to practice solving equations as a skill in one of the other reviews. Okay, let me know if you've got any questions. Have fun.